making sure everybody can hear me in the room. Does the mic work at all when it's down here? Should I blow? You guys can hear it okay?
I hear you.
Is the filming, guys picking it up? Okay. Awesome. Brianna, are we close to being set?
We're good.
We're good to go. So let's go ahead and get started. Thank you, everyone, for the TTI members or the EEA members, and those that are not members. Welcome to sort of our overview of the Token Taxonomy Framework. Before we get started, I do want to get rid of my, thank you, get rid of that. I want to set some context here. The Token Taxonomy Framework is the primary, or the first sort of deliverable that will be the TTI, the Token Taxonomy Initiative, which is the blockchain neutral organization. So we have sort of everyone in the organization that joined is either not just Ethereum but other platforms as well, whether it's IBM or Digital Asset or R3. But in the interest of producing sort of this common taxonomy that we can all sort of charge the hill together instead of individually to tackle some of the biggest non-technical problems that we face, namely around education and regulatory concerns and misconceptions and a whole host of things which we'll get into in a bit. Before we do that, some of the value of the TTI that I want to talk about. First, we'll talk about at the beginning, sort of set the stage. So why are we doing this? What's the value at the end of the road for participating in the TTI? And it is, once we're done with this framework, and I'll give you an overview of what the framework is really built to do. But once it becomes useful, it's because of everyone's participation. If no one participates, it's not very useful. And you'll see why as we go through. But once everyone participates, then everyone will be able to reap the benefits of that by, again, having that same common language, the same ability to go tackle obstacles together, but also we'll be offering a certification program. So members of the TTI, the taxonomy, anyone can use it, but contribution to it, and also getting your solution or your token implementation or your exchange or whatever it is, we will be going through a certification process that will help build the trust in the members of the organization and the output of the product that you have delivered using this taxonomy. And that also helps us sort of push towards interoperability, which is the other main goal. How do we unlock the value of tokens across these ecosystems, which is often very difficult. I got a question about who keeps wanting to annotate my content. Can the WebEx folks hear? Do I need to stand closer to my computer? Can we gauge that?
We can hear.
That's kind of weird because you're in the room. Okay. Did anyone respond on the WebEx?
Yes, Eric Cohen said we hear you well.
Okay. Like, is it well in the hole in the ground, or? I'm kidding. So, all right. So with that, we'll come back to the TTI. Now, the audience that we have in the room and around is a mixture of business people and technical people. So I'm going to give you a context. This initially spawned out of how I approach physically very complex things, and then have to try to figure this out in my own head, but then explain them to other people. Hopefully this will make sense to you. So I'll start on a little bit of a journey and talk about the TTI and go back to when I was a kid, and this will date myself. Stretch Armstrong, I don't even think anymore. Is it still? Okay. So when I was a kid, I was super obsessed with, I had to figure out how things worked. What was inside, what made things tick. So I would do some extreme things, like early on, my early toys. Butter knife, not going to cut. I couldn't leave any sharp knives. Flathead screwdriver looks like it could be dangerous, but not Stretch Armstrong. But hammer and nails, that worked. Especially when you can get some serious, I was pretty good with a hammer when I was a kid, making tree houses and such. I was rather disappointed in the outcome of that. I don't know if anybody else did this Was it just me?
Not quite so much.
I had an eye on the saw, and we had a saw, and I just couldn't. My mom would, she busted me like before I even got to it. But she actually let me take the nails to it, which is kind of cool. His head pops off. It's not. The body's just goo, and it's just not. Anyway, so, but you know, I kept doing this, and I would get the more complex things. Like this is something called Merlin, and I borrowed my neighbor's Merlin, and I took it apart. I couldn't put it back together again. I got in trouble for that. And I should learn my lesson. And then I borrowed it from my neighbor again the next Christmas. This other thing, and I took it apart. I can't remember what it was. It was this tube thing, and it shot things around, had a fan in there. I took it apart. I could not get it back together. And I always end up with like spare parts. Everybody's done this, right? I'm not the only one. And I got in trouble for that. So I stopped taking other people's stuff together. But I had more fun taking stuff apart than I did playing with it. Maybe I'm weird. So I did get busted a good bit. But I did learn some valuable stuff. I learned that putting stuff together again, the most crucial thing is how you take it apart. Right? You learn how to do things the wrong way. We make lots of mistakes. So I learned this early on. I said, you know what, there's got to be a way for I can take this thing apart safely and have confidence that I can put it back together. Because really, it's more fun to take other people's stuff apart than your own stuff. Because it has risk, right? Anyway. So, one of the things I learned was, hey, take notes on where things sit. Get a piece of paper, a pen. I mean, literally when I was a kid, a note paper. And I wish I kept that. Anyway. But I would do weird things like, if I didn't know what something's name was, I would give it a name, so I would have to give it a taxonomy, right? So I use names that I thought were appropriate for items that those are clearly 3 flux capacitors, as you all know. And then you group things that are together in piles, so that if something goes astray, and if it's only one of them, then those are like specialty items. You have like these are like dime a dozen. You get a couple of those, but you get these like weird little things. You have to treat those very special. You put those in a special place and make sure you really know where that thing went. And that also helps you figure that stuff out. So this is essentially a kid describing how to decompose things. It becomes a decomposition framework, which is not all that useful unless you intend to actually create a composition framework. So once you learn how to decompose stuff, you then have a composition framework for being able to put not only the stuff that you took apart together, but the things that you took apart that you ended up with extra parts. You can start to create new things, interesting things. So sort of like Legos, right? Everyone here started out with Legos. My kids, we would go buy the really complex castle or the pirate ship, and they come with 5,000 directions. And we go through that thing. It's just like brutal going through it. And I was like, you know what? When I was a kid, I didn't have that. You got a big bucket and you had no plans, and you just had to put your stuff together. Anyway, the kids use that now. They take it apart. They just play with it. So you get your parts. You get all these missions parts. You put your parts into categories. And we say, categories of stuff. So I have like foundations. I want to build a building. Okay, I need a big foundation. Right? Everyone kind of knows this. This is bloody obvious. So I have like parts that do things. And then this is the parts that go together all the time. And you can take these shutters off, but they're not really useful anywhere else. So just leave them together. They always go together. Generic parts and specialized parts. Anyway, this is essentially the approach to this. So the Token Taxonomy Framework is essentially this. It's parts put into categories. So you can snap things together to create a spaceship or a boat or a dinosaur or a spaceship boat for dinosaurs or whatever. Right? That's the intention. That's what we're striving for, is to be able to create these things. Now, I am speaking abstractly, right? But this is the direction we're trying to move things in, to do this. So as we go through the exercise, I'm going to describe these things. I'm going to describe the framework itself. Hopefully everything else will sort of snap into place. So, what is it for? Again, one of the things that we're going to get out of this taxonomy is we're first going to be able to educate the world. Business people have a large number of misconceptions, regulators, industry groups, and there's been some bad press over the years. So we need to sort of reboot the conversation around tokens. And then we need to establish a common set of terms. There's a wide gulf between your technologist community that are talking about ERC20s and all sorts of fungible, non-fungible, and you start throwing these terms around, and people glaze over, become like Krispy Kreme very quickly. That's a technical term. Not pure Krispy Kreme, sorry. Donut glazed. Anyway, so we want to be able to establish this common set of terms that lets us start to define in a consistent way. That's the other thing. We all have to use the same sort of consistent way to define things, or else our definitions aren't going to work and they don't match up. And we don't end up with Legos. We end up with Duplos and Legos. They don't go together. You can't use those things together. So this lets us create definitions of implementation neutral. And this is the real benefit here. The other thing is the benefit for the people that are doing implementations. It's really hard to get solid requirements from business people when they don't understand what it is you're trying to build. So this enables us all to agree on the terms, but whether you're technical or non-technical, and also to understand and define requirements in a common way without confusing anyone and getting clear sets of requirements so that we can all go implement this in our own ways, but following the same requirements, we should be able to get consistency across them and move this ball forward. This is not not implementation specific. Everything you'll see here is very generic. It's not a legal framework, but it's intended to be extensible. And you'll see this as we go through. This is sort of designed to be a hub to much more specific spokes or reference material or code or implementations as we go through. It is not complete or comprehensive right now. What we're going to be covering right now are the building blocks, right? We're not going to cover every single token. We're not even going to define a new token. We're just defining, this is how we'll define this is going to be our methodology. These are the groups that we're going to put things in. This is how we're going to describe these things consistently so that we can all use this taxonomy. That's the power of this. Now, it seems somewhat trivial. It's a lot easier. I'm telling you, the work that you have to do to create a single token implementation is trivial, well, comparatively speaking, than it is to decompose the thing and really take your time in understanding things. But over time, people that use the taxonomy versus the people that are individually building these tokens that are sort of, they're not designed specifically for reuse necessarily, and they'll go over here and you'll go much, much faster, and you're going to get a lot more cross-industry collaboration here. All right, so let's go through the taxonomy. So the token taxonomy, first we established some basic fundamentals in terms. And my team, we built some of this information we built actually internally just to get developers and stakeholders within Microsoft to understand these concepts. So we're going to establish these, and we'll walk through these. We have like terms like what is a template, what's an instance, and what's a class. Let's talk about a token template, or the end product. This is what you want to end up with. A token template is a definition, right? It is intended to be reused over and over again, so to spam the world with copies of itself, because it is a concise definition of what your token needs to do. So it's essentially that recipe. Represented in a formula. Don't need to know what this formula is right now. You'll know later on. It's not as complex as you think it is. But we have these things built as symbols. These symbols actually link to our piles of Legos. So we have base types, we have a pile. Those are our foundations, the big green boards. What size are we using there? Our behaviors, those are the wheels, stuff that does, things that do stuff. Behavior groups, those are the windows, the shutters. They go together all the time. Each could do things individually, but it's not really useful without them. And then we talk about property sets. Those are sort of our specialty items. That little special part, there's only one of them. Don't lose it. Very important. So hopefully this analogy, it will follow pretty soon. But So we start with that. So we end up with that. And then we take that formula and say, these formulas are represented by symbols. The symbol is just a link. Think of it as a hyperlink, but a very simple one. And we call it an artifact. It links to an artifact. And an artifact is just a set of text files in a folder that actually we are going to be contributing to define these tokens. So we have token template. Now, when you take the token taxonomy and create an implementation, meaning I go and I write the solidity, or I write the chain code, or I write the flow code, or I write the DAML, or whatever I'm writing in. I write it against that, and I say, here's a implementation of that template, and I can deploy that template formula to a network. When I deploy that, it becomes a token class of that template type. With me so far? Okay. That sounds simple. And then we talk about an instance. This is where you can easily get confused between a class and an instance. An instance is actually the ownable token that you have in your wallet. It is an instance of a class, of a template. All right, so everything sort of rolls back up to templates. If we do this right, we'll be able to go around the world at any network and go and look at a token instance and follow it up to its token template and understand what that thing does, especially if it's been certified. Hey, this thing does this behavior. We know it does that behavior because it says it does it. It's using this template. Everybody with me? Yeah. Shouldn't be too technical. One question in the room.
Yes, one quick question. So it seems like you're taking it's almost like an Armstrong programming and putting it into naming for classes. It's kind of very
It's similar. The question was around if that's similar to object-oriented programming. It is, but also if you go look at biology, I went and looked at taxonomy, and I looked at sort of the evolutionary stuff. They were using these terms. They weren't using templates, classes, and anyway. But it's useful though. To that mindset, actually, I did approach it that way as a developer. So, one more question. We do have a microphone. I'll repeat it for the WebEx.
So just for an example, your token template would be ERC, your token class would be 1400, your token instance would be a token in someone's wallet that's based on 1400.
Yeah.
All right?
Very, yeah. Yeah.
No, isn't it the other way?
Now, the ERC, if you take ERC and you reverse engineer it and you apply it and we've already done this before, but it's pretty straightforward to write an ERC20 token. And you'll see the formula. So that's what the token taxonomy is for an ERC20. And then you say that's the template. The class is an ERC20 that's been deployed to an Ethereum-based network, whether it's Quorum or whatever. That's the class. And then the instance is what you would have as an ownable instance of that. Oh, another question, real quick.
Wouldn't the template be the generic, essentially the data model? And I would think ERC20 would be the implementation of it for Ethereum, and then there would be the same definition would be applied to
it would be.
Yeah, so the template is not ERC20. It's issuing a token, or like whatever you want to call a fungible token would be the template. The implementation of a fungible token would be ERC20, and there would be something for Hyperledger Fabric that implements that template.
Yes, that's what it says. You take ERC20 and you break it apart, and you reverse engineer it into this, and then you get the ERC20 formula. You don't need to call it ERC20.
Formula is the template.
Is the template.
Okay, got it.
So so you're right. Okay. Oops. So we already talked about the categories. We talked about base tokens. What was that here? We have base tokens. We have property sets, behaviors, and behavior groups. These are our piles of artifacts. So artifacts, when you create one, they'll all fall in one of these piles. And we'll talk about tokens are just composition. When you get a token template, it's not really the definition of a token template. Is you point to and reference to all the other symbols that are defined as individual artifacts. And that's where the formula comes from. It's not this complex physics, you'll be able to go, oh, okay, I know exactly what this thing is. You look smart when you put it up there, like it's really complex, but it's super simple. But we'll go through this here in a moment. The tokens essentially, that usually have a common base, and we'll talk about some of these in a moment. But you go out, you differentiate yourself from the numbers of behaviors, the different behaviors you implement, and then the specific property sets that you have. For example, a token, I can implement a fungible token, right? But I want to make sure if it's used for inventory. And inventory items have a SKU, right? If I create a fungible token to represent items of a particular SKU, I want that token to have a SKU property. So I can send it a get SKU request, and it's going to send me back the SKU number or the SKU for that token class, right? Stuff like that's declaring a property that you want to have. So you'll differentiate that. Now that same exact thing for inventory item, you might have the same formula minus the SKU and change it to, I don't know, QSIP or some other industry acronym that applies, right? So that's how tokens start to differentiate themselves. Okay, let's talk about artifacts. There's really nothing magical here either. The most powerful thing about artifacts is we define things in a common way, and that means that it has data structure. We don't just let you do ad hoc. We have places where you can do lots of free-form writing and things like that. We're not in here to write technical code. We're in here to describe things that any general person or line of business executive can understand and get. And we'll have also analogies and things like that. So you'll see these artifacts. And then behind them, we'll have metadata. And metadata is also super powerful. And most consumers won't really care about that. But the metadata in the back end makes this thing programmable and linkable. So you use it to reference out, and we can use it to do all sorts of very, very interesting things. Everything you'll see in here, we'll talk about the taxonomy itself. It's just we're using GitHub as essentially the taxonomy exists and lives and breathes on GitHub. So you'll be we'll go through that a good bit more. But it's really designed to be. You have these extensible categories. We have a common set of artifact metadata across them, and it's designed to be extensible. The GitHub folder is remarkably simple. So there's really, we don't want to be too complex, but we just we have a root artifacts folder in GitHub, and then we have folders for each of the main categories, and then we just start plopping in artifacts as folders underneath. Now those folders have multiple files. We'll talk about it in a moment, but they're all human readable if you wanted to read it. Some of them are JSON, which is not really human readable very well. I mean, you can read it, but nobody likes reading JSON. I mean, you can get your novel from Amazon in JSON if you like it. Don't recommend doing that. See if anybody's awake this morning. So we'll talk about that, but there's an object model like that, so it makes it easier. Everything's, we name things appropriately and things like that. So let's talk about the building blocks, our big green pieces or foundations. We have fungibles and non-fungibles, and this T is called a tau, the Greek symbol. We'll talk about symbols in a moment, but we have visual representations of the symbols, and then we have what we call tooling symbols. This tooling in programming about the tau is represented by special characters, which is not really good for back-end stuff. So we have a tool. You'll see that pretty simple. But you'll have definitions of fungible. That's where it's like money and physical money, and we'll have a definition for. In fact, that's going to be in the base framework, what the definition of fungible means. And then non-fungible, and we see the token is pretty straightforward to understand what that is. So non-fungible, those things are might be in the same class but have different values. So I like to tell people that this is like money and this is like a property title. So if you own a piece of property and you have a title, it looks a lot like your neighbor's title, but your property doesn't have the same property value of your neighbor's. Now, if you could change them and your neighbor lived in a mansion and you lived in a trailer, hey, that's fungible. It'd be a good deal for you. Doesn't work like that, right? Then we have this notion of a hybrid. Hybrids are essentially a combination of the two, and you can get fairly complex with hybrids. Let me just describe what those are. So a hybrid essentially says I have a root or a parent token, like a non-fungible token, and then it can have classes of child tokens. So let's talk about, let's say Metallica is coming to Madison Square Garden, or let's go bigger, Shea Stadium, is that what it's called? In 3 days, Metallica's coming, they're going to sell 3 days in a row, and everybody goes out, and you can go buy a concert ticket. Now there's a ticket for Monday, a ticket for Tuesday, and a ticket for Wednesday. When I buy a ticket, I have to buy it for one of those specific days, so it's non-fungible. I can't buy a ticket for Monday and show up on Tuesday and use that Monday ticket, right? But I'm also in general admission, so I buy a Monday ticket general admission, which has a non-fungible route, but general admission is fungible. If I'm going to storm the stage, it's where I get in line. If I get in line when the gates open, I storm the stage. I get fun. You know, I get in the mosh pit. Just seeing if anyone's awake to one, but those are fungible, right? But then I want to have some reserve seating. So if you buy reserve seating to a Metallica concert, you're not cool. Just saying. But that seat is non-fungible, meaning if I paid high dollar to get in the champagne room for the, we'll do that either. The Metallica show, that's not fungible. You're not going to be trading your reserve seat for somebody in general admission, unless you just want, you realize what a jerk you are for buying reserve seating in a Metallica concert, and you just have to, you know, go mix it up, and then I encourage you to do that. So that's essentially a hybrid. So that's a non-fungible with a set of fungibles and non-fungible. So it has a parent with 2 children. Now flip it around and say, okay, let's take mortgages. Go back to the mortgage. We said we create non-fungible mortgage tokens, but we want to create a security, a fungible token that we can have be the parent of all those mortgages, and then I can sell tokens and sell tokens of that fungible parent to many people to allow many people to own fractions of all the underlying mortgages. Another very common use case. These are hybrid scenarios. Now, some of you might be jumping directly to implementation. Don't do that, because then you miss the business requirements. And this is the most common thing I see especially when we have people that are coming from blockchain for a long time. They jump right to code, and they miss what the point was. The point is, let's step this thing back and really define these things well. All right. Properties. So we have, properties are 2 different types. We have behavioral properties, and those are properties that come with behaviors, which we'll talk about next. And then we have non-behavioral properties, and these are just properties like the skew I mentioned before. So if I know I need to have a skew that applies to a token class of this type, so if I'm going to create an inventory token, and I'm going to create a token for everything that I have, and I have 50 SKUs in my portfolio, I'm going to have 50 tokens. Each one's going to have their own SKU. But I know each of those tokens, I can send a get SKU request, and it's going to give me back the SKU. I can do that for any of this. That's what a property set is. It's not really behavior. It's just saying, hey, I've got this property. I don't really do anything except I store a property. Okay? So that's a property set. Pretty simple. And we use a symbol. We're using P for this. And again, it's just, you can name a SKU, whatever. You'll see how these things fit in there. But these are ways for you to explicitly say, I need these types of things. Now, behaviors. A behavior describes a capability. And these are usually verb-based, like transferable versus non-transferable. So a transferable token, is one that you could obviously change ownership, which we typically think of fungible tokens as being transferable, right? It makes no sense, for example, to have a non-transferable fungible token. What? What is that for? But we still need to describe what non-transferable is, because it's a concept that will be important for like non-fungible tokens. That's non-transferable. What would one of those be? If the U.S. government suddenly says, here's your vote token, citizen, that should be non-transferable. I should not be able to transfer my vote token for someone else to vote on my behalf without anybody being the live. So these are what behaviors are. Behaviors are a capability or a restriction. We'll talk about syntax in a minute. And those behaviors can come with properties. So you might have a behavior that says, if you implement this, and we'll talk about one called roles in a bit, and we implement something called roles, this role support, then with that, you need to have a property on your token that supports the notion of a group or a role. That will be a property there, that the behavior brings that along. That's the difference between a behavioral property and a non-behavioral property. Seems like nuance at first, but as you start to practice it, it starts to make more and more sense. Oops. Control messages. Property sets and behaviors have these things called control messages. These are message descriptions for how you either invoke a behavior, what do I need to provide in the invocation of a behavior, and what I'm going to get back, and why. It might sound trivial, anybody's done programming, this is just essentially defining an interface. But it comes back and lets people articulate the business requirements for, if I'm sending a transfer request, I need to say, who am I transferring it to, and how much am I transferring? And I need to get back a receipt. Or if it doesn't work, I need to get a reason why it didn't work. And let me describe those messages up front so that the people that are implementing understand what my requirements are. Now, these are descriptions that are neutral, and you'll do it for property sets as well. Get SKU request has a get SKU response. And we usually name them where anyone can see the message name and know what it does. A property set that gets SKU request, I can explain what that thing does, and it's going to return back in the get SKU response the actual SKU. So that's all what control messages are. They are defined in the artifact for the property set or the behavior. Make sense? Okay. So common behaviors. In the taxonomy, it's not going to come out at first with every behavior. We took some of them out that we knew about because the taxonomy came out of Microsoft, and we quickly realized, hey, we don't know exactly what our customers want to do. Let's just get a consistent way there and let them actually define it. I want the financial services lines of businesses to define behaviors that really apply to their domain. I want the healthcare people to define the behaviors that really apply to their domain as well. But what we get out of the taxonomy, so we do have some as examples. So these are sort of generic, transferable, non-transferable, subdividable, or whole. So subdividable, that typically applies to, well, it can apply to either, but it lets you split it up into a fraction of a token. Most tokens are familiar with that. There's some tokens that makes no sense, like a SKU. You don't want to own a fraction of a screw. That's a SKU. It's a whole token, right?
I don't know if I'd use that analogy.
Yeah, okay. Screwdriver. Maybe. Anyway, well, these are the ones, Mintable, role support, and burn. We're just going to have the generic ones that are coming in the framework. And now, like the Lego shutter window thingy, we have property sets. Behavior groups. Behavior groups are just behaviors that typically go together. Frequently found like a Reese's cup, put peanut butter and chocolate together in nifty packaging. It's a good item, so just create a behavior group that includes those. So it's just a shortcut way in shorthand. Say supply control includes mint, burn, and roll support. And it lets you do that. And it also encourages decomposition. It is also very tempting as you're going through and you're defining these things for you to create sort of a behavior that actually should be split out into two behaviors. We try to make it not cool to be lazy, and really think about, because this encourages us to fully decompose things. It's going to give us maximum reach, and that's going to be the value in the long run where we're going to get the most value. Okay, let's talk about grammar. There are rules here, and we'll talk about some of these, but the first one is just how you start. All token templates start with a token type, whether it's token is fungible or non-fungible or a hybrid, and you can see the combinations here. When we get in the hybrids, you'll see who the parent is and then any children that you might have. Now, the interesting bit, I want to get there, but these could actually be hybrids as well, so it can get more complex. You can get sort of a nested like tree, but you can really describe complex business if you want to. So that's the first part of the taxonomy. Once you get through these and you look at a token formula, behaviors themselves have a single character, or if we run out of letters, we'll just do two and you'll end up with acronyms. But they're lowercase. In visual form, they're put in italics. In tooling, we don't use italics. It's lowercase. They have to be unique. Symbols have to be unique within their pile or their group, right? So within behaviors, each behavior will have to have a unique symbol. A behavior group is using uppercase letters. Straightforward. Whole token components start with a base token and then followed by a collection of behaviors. Put it in braces with a comma between them. Very simple. You can mix these together because ultimately at the end, when this goes through, it's going to map. It's going to pop in mint, burn, and roll support. That's what this are. So we let you plop them in the same place. The notion here, things have opposites. So this is non-transferable. If it removes the tilde, then it's transferable. Really simple switch. Not all behaviors have that. Some of them are just obvious. Some of them are not. And then we have, let's see, some examples. So that here's a hybrid where we have a non-fungible theater ticket, a non-fungible route with a set of fungible, so everything's general admission, that's like a movie theater, as I remember seeing. A barrel of oil. Where's Tony? Here he is. And then we have this thing called an inventory. This is where we get to the full source syntax. This is the one I've been talking about. It's a fungible token that is non-subdividable, so it's whole. G means it's delegable, which we'll talk about in a moment. And then it has supply control, meaning I can mint new ones and I can burn new ones, and I have role support. And role support means I can grant others the ability to mint new tokens in my class. The barrel of oil is a good example. If I have a bunch of people have a token for a particular grade of oil, and I have 4 producers, and I can make each one of them have the ability to mint tokens of that class. That's role support. Pretty generic way to describe it. And then we add a SKU. And because we're adding the SKU, we put braces around the entire thing. And that encompasses, we don't need to put the braces there, so it's, if you don't see the braces, then you know it doesn't have a property set. Yes.
Can you give an example of, like a real life example of minting and burning?
Yes. Minting and burning. We'll get to the definitions. Minting is real world example, and let's go to the barrel of oil. We have suppliers, tokenizing barrels of oil. They don't do this. As they fill up a barrel, they put the cap on it and they create a token for it and throw it in inventory. And then once it's in inventory, then somebody can create a trade and encumber and grab that barrel of oil. So I'm trading 10 barrels of oil, and it will grab 10 tokens of that grade and trade it. And somebody picks it up, and the barrels of oil change ownership. They get delivered at port to a refinery somewhere, and they get poured into the refinery machine. And when they're poured in there, that barrel of oil gets burned. So it's no longer available. Pretty simple. It's a way for you to add and remove inventory. Now, you have to actually own the token to burn it in this case. But once it's transferred ownership to the refinery, it's their responsibility to burn the token for the oil once it's been refined. So that's an example of mapping, sort of real world life cycle of a token using behaviors like that. So some additional rules. We have this behavior called delegable, which can apply to an entire class. And there's a notion of transfer and transfer from. For example, there's lots of fungible tokens that you might that are pegged to currency or have value like a cryptocurrency, that I might have a wealth advisor that I want to delegate a certain number of, have them be able to transfer on my behalf. So I can give them an allowance, say, hey, you can transfer or mess with up to 10 million of my tokens to invest, and that's delegating that responsibility. If I mark something as non-delegable, then transfer from will not be available. It will only have a transfer, meaning only the owner can transfer that token. So this is just one. It's not really it's one that can apply sort of broadly. And that's what we call influence. So we have behaviors that might influence. And then you have behaviors that are natural opposites. We talked about this a bit. Transfer and non-transferable is just using the tilde in front if it's not. And then some behaviors are incompatible with others. So like if you can't apply non-transferable to a fungible token, maybe we decide at some point you can, it makes sense to do that, but I don't know. There's several things that could be incompatible. We have a way to mark that in the taxonomy. Question?
Quick question. So first of all, this is really interesting. I love the framework. I think most all tokens I've seen would fit in here one way or another. For the transferability on fungible tokens, can you kind of unpack that a little bit? Because we've seen, fixed cap tables or lockup periods, and it's generally like toggleable, but like there are a lot of instances where you want a fungible token to be like non-transferable.
Yeah. So the question was, can you drill down on the transferable of that? And the answer is no, because the group, the contributors, the people that are in those issues are going to contribute transferable and add that to the behavior. And we might say this is transferable with, it might come with another property to be a property set. Another behavior to go with a behavior group that would have sort of ability to put restrictions or a hold or whatever you need to do. You'll be able to describe that. So we want people to contribute that. So when you run into this, you come up with a new model and you want to plug it in the taxonomy and explain it. And then you could say, hey, here's generic transferable. I pair it with this other thing, and I create this property set that meets that business requirement. Not that I don't want to go into that issue, but that's really what we're trying to get people to lean in.
Interesting. Yeah, not sure I agree totally there, but
I'm not saying that's the only way you would do it. I'm saying that's what we're all in the room to do. The organization is designed to go, let's have people that know those issues define those, because they're going to be in every industry. Okay. And then we have other behaviors that are implicitly based on the next token, like transferable is implicit for a fungible token, so you don't have to say a fungible token is transferable. Things like that. But those are all, you have the ability to express that as a requirement in the taxonomy itself. Now, when we start to do this, we'll be able to classify tokens in relation to other tokens. We have all tokens start with a base called T or tau. And tau has some generic things that both fungible and non-fungible, things like a name, an owner, that kind of stuff. And then you get the actual implementable, the fungible and the non-fungible hybrids. Hybrids, when you create a hybrid, those will have their own sort of branches. Actually become hybrid branches, and they become this visual nightmare right now. But the taxonomy will let you navigate those things. But you create a new branch from a parent when you start to add behaviors to your token. So if I start with we can look at the first root is tau, and then tau fungible, non-fungible, and then the next level is it dividable or subdividable. And then from there, it's like it can go really wide. But we'll start to see it go deeper when you start to have a common formula like the inventory item that will be a branch. Then inventory item with skew is a leaf on that branch. Inventory item with a QSIP is a leaf on that branch. And it's just sort of, it doesn't, you can't like say, show me the entire taxonomy in a visual tree because it just goes really wide, really fast. But it will let you pick a token and see where it's in relation and navigate a little bit. So here, yeah, we just talked about the hierarchy. So we can have tokens that create the actual definition itself, minus any property sets, creates essentially a branch, and then things that implement that formula with just adding the property set creates a leaf. And the good part about that is if you're defining that, you say, I just need this property, you don't have to go create, you can just use that formula over and over again and keep adding different property sets, and you get the reuse out of that kind of stuff. Let's see. The metadata itself.
I noticed that there are some questions that are coming in online.
Yeah, we'll get to the questions online.
Are you going to share the slides later?
Yeah, all the slides will be shared.
Okay.
Yes, you don't need to.
Okay.
Yeah, all this stuff is. If you're a member of the TTI, it's all in the GitHub repo. All this stuff is there. As we start to see the tooling artifacts, this is again sort of going into the metadata. But one of the features of the metadata is on each artifact, we have what we call a map or maps. And the maps we've identified so far is a map to source code. So for example, in the Ethereum community, you can grab the mental behavior and you create a map. We actually already have this, and it goes to the Open Zeppelin code on GitHub. And it's just a link to that, so you can go to link directly. It's not the code; it's a link to it. You can do that for every artifact, including a token definition. Those token definitions can link to source code for implementing that entire thing, or to an actual implementation from a third party. So if you're in the token business and you're creating token, you're creating this, you're selling it, and people model out and they figure that, oh, I just described this token. Click on this and say, oh, there's already an implementation for this network type, and take me to that. Let me go see that solution or that token so I can buy it or whatever, license it, whatever that would be. So these are what we call maps. We have maps for the source code, finished implementations, and then resources. So we also want to be able to link to regulatory guidance, for example, regulatory frameworks, whatever. Every industry is going to have some sort of reference that you might want to link to. So those are included in the metadata itself. All right. So once we start people contributing to this and we start building this library up, and people in the healthcare industry just start defining behaviors, the people in financial services start defining behaviors, and the healthcare people find some token they're creating maybe for a claim or something, and they want to make the claim have an insurable token or something. They don't need to be concerned with defining insurable token. They can just go find the insurable behavior or healthcare insurable, whatever that would be in the taxonomy, and say, I'm going to have this behavior and tack it on, be able to add those requirements. So it's going to start allowing us to cross-pollinate these parts, these Lego parts, and share them and say, oh, you want to work with me? I've already defined this. And yeah, I can finance your invoices, or I can finance your accounts receivable, or whatever it is you're trying to do. It allows you to start collaborating that way. Here's just an example of the hierarchy. This is not the actual hierarchy. It's just an example. Don't get hung up for going, oh my gosh, I can't believe you put a deed under a transferable whole token under non-fungible. That's just, why would you do that? I mean, that's not what it is. This is a visualization example of what you could possibly get from that. So let's talk about how this thing we anticipate being used. Once the taxonomy starts building out these definitions and you have these artifacts with all the metadata. Now, I'm not showing what a typical user would see. We would put like real names. We would put non-fungible or fungible, but here, but put the symbols. I could grab from a palette, like my Legos, and grab my foundation, drop it on a design surface, and then I have these palettes of behaviors, property sets, and behavior groups, and I can just drag them on and drop them. And it will do things like, if I try to drag something that doesn't work with another behavior, it'll warn me and things like that. But I can create this. This will be from a business user perspective. We let anybody sort of do this, and it's agnostic, right? It doesn't point to any implementation. It says, these are what my requirements are. I want to build one of these. And once I say, this is what I have, find this in the taxonomy. Is there something already defined that does this? If so, then I can then say, oh, if somebody's already done the work here. Has anybody written the code yet? Oh yeah, here's the implementation, or here's the the solution for Hyperledger Fabric, or whatever. Be able to link to that. So that's one way. Now to do that, how do we get the taxonomy populated? And this is where the organization and everyone collaborating together. So we've done lots of open source work at Microsoft, and we've done some badly. We've done some, and we understand how not to do it. The first thing is, you don't start an initiative with no code or no contributions, and then get people to join it, because it never goes anywhere. And you also don't start an organization and contribute 100% of the code with a finished product, because then nobody wants to join because they can't contribute. So by design, we said, here's the taxonomy that we actually took some stuff out, because we don't think we accurately defined it. We were just sort of guessing from what we learned with customers. It's better, what we said was, let's focus on getting consistency in the way we define these things and decompose them. And then we'll have some examples. And then we need to have tools in this platform to support people going out and workshopping. Whether you're an existing token implementer and you have a token that you have in market, or one that you're getting ready to take into market, go and apply the taxonomy, reverse engineer it, and see, is there something new that you can describe? Is there something that you can contribute or validate, or that you want to get certified? That kind of thing. People that are looking at designing something brand new, existing or net new business case. So this workshop, we will have a process, and it'll become part of the taxonomy. So anyone can do this. There's no rocket science here. Because it's in GitHub, the taxonomy has the ability for you to fill in an artifact without programming at all. There's a web interface, a Word document, a Google Docs, that in the back end, it actually has the taxonomy. So you're not having them like and edit JSON directly. They're working in a template or a front end that talks to an object model, and the object model serializes back to GitHub. Don't get hung up on that. It's a technical thing. But the thing is, it's built for reuse, and it's easy for you to add and modify and update artifacts using everyday tools that everyone uses. But on the back end is integrators and linkers, and it's also, we can use it as developers and pull that taxonomy in and reason over it and create experiences and designers and all sorts of things with it, with the taxonomy.
Taking all the fun out of it, though.
Taking all the fun. No, there's plenty of fun left in this. But this is the intuition. When someone does the workshopping, they'll go and they'll fill in these forms, and they'll say, hey, we've done this. Let's contribute it. And the contribution process is using a process in GitHub called a pull request. And don't get hung up on that. But essentially, it comes to the TTI. We look at it and say, hey, is this unique? Or is there something else in the taxonomy that does the same thing? If it's unique, then we say, okay, well, it's a symbol unique. All this letter's already taken, and we need to give it this letter or whatever. And we say, hey, this looks good. We'll merge it, and then it gets put into the regular framework, and then suddenly anyone else will be able to see that artifact and reuse it, or make it better, or both. And the more and more we do this as a group, industry and implementation agnostic, that means the Ethereum community, the Hyperledger community, the R3 community, digital assets going to have stuff to say in this area too. But we're the platform providers, IBM, Microsoft, digital asset, R3. We're not going to describe it. We're trying to say, let the customers tell us what you want. Regulators, tell us what we need to do. How are we going to capture that, what they tell us, so that we don't all have to repeat this exercise? That's what the taxonomy is for, and this is what this process is for. put this information in a common way, common format, so it's reusable, and it's decomposed at the right level so that it's useful. So, I know we have lots of questions on the WebEx. We'll take one in the room, and then somebody will bring on, or you can start tipping off on the questions on the WebEx.
So this is Jim Tomonto from IBM. There's, I've kind of seen parts of this presentation before, and not representing IBM, but representing myself. I think there's so many big ideas and so much brilliance in what you put together, Marley, that I'm blown away. And I think the number one thing that really strikes me is if we look at the history of humanity, the only way that communication has gone across societies is by mathematics. And you've essentially given mathematics to smart contracts and to systems of asset transfer and money. And I think that's the biggest of the big ideas. You've just created a language, in my humble opinion, a language that we can all use that will probably exceed our time on Earth, my personal time on Earth. And I plan to be around for a while.
Thank you. You take Bitcoin, right? I know you said I had to pay, but I didn't say how much.
Good, it's visible.
Okay, that was a comment on this question, but,
Okay.
I was wondering how you are considering handling something like version control, and say something like insurable changes.
Yeah, so we will have versioning, and we'll cover this. We'll talk about it. But there's a versioning for the taxonomy where we can version the entire taxonomy, and you can version individual artifacts within the main version. So you can have multiple versions because GitHub will let us do that. So we'll be able to. You'll be very specific in the implementation, and part of the formula. We're going to have we didn't want to put it in here, but there's a version signature for each one that will be a part that will come across. So when you reference it, it will, when you pull the symbol, it'll have a version property. We don't just, we try not to add that layer of complexity. That's a very good question. It's actually something we need to get, where's the right place to put that? So that'll be one thing that we talk about and make sure. We think it's in the symbol itself, so it's easily spam, you get it, but it might be better to put it somewhere else.
You also mentioned about the certification and all that. So
Yes.
what's that all about?
Certification, you pay me. We are working, so we're using, Dave here, and we have the team. We're going to be coming up with a certification. The certification is, as we get through, and part of the group here is we're all going to agree on what does it mean to certify, but mostly around the definitions and the behaviors. Now, it's not, most people think implementation, you're going to be validating my code. It will not be like that. We'll have test harnesses that say, says you implement this behavior, you know, we'll work against it and see if it actually does. We said we need to send it this control message, or we need getting this back. Does it? Now, however you implement it, it's up to you, right? We'd like to see common implementation, but we're not going to do that. But as long as that happens, then we'll do the certification at that level. Now, I think this will come in phases. Really what customers want that we hear are, especially the big enterprises, we hear that, hey, I'm going to have a foot on several networks. I want to have a foot on the public network. Then I have these three consortium, and they're all using something different. Help me make these things interoperate with each other and exchange, like move things around. We're not going to get there right out of the gate. This is the first step in that direction.
Can I add to that?
Only if you get on mine. So,
All right, thank you. I'm just going to add to that because that's the world I come from. So we're trying our best to implement a way to create a solution where vendors who sell blockchain or tokens can be considered trustless, the same way there's perception that blockchain is trustless. And the standard, best practice way that it's been done over years, and I come out of telecom and other industries, is through a certification model. And the way that works is it's very interesting what you need to do to make it work. And to Marley's point, you have to define what the features are that you're looking, for example, in this taxonomy, that is strong enough that the customers who are going to build tokens
feel that there's some meat to it. So it can't be too loose. It can't be too rigid, like what he's talking about in code. It's the exact same kind of model. And so what we'll do is we'll work on defining the features or the components of what a token taxonomy framework is. We'll have a logo, and then based upon that, we're going to have an independent third-party laboratory, and we have one that's folks would trust is credentialed, and regulators would trust and believe that they're doing the right thing. And all you're going to do is really get it. There'll be some tests that this independent lab, not tied even to the initiative for protection, because everything is going to be proprietary, will test. And then if it conforms, if this logo activity, if the work on the token conforms to the TTF, has nothing to do with the code or anything like that, you'll be able to use the logo. So where this helps is it builds a lot of trust. When you're going to create tokens or a vendor is looking to shop around and they want to have more than one vendor, you could put in an RFP, and this is how I've seen it like it's done all the time, saying you need to make sure you conform to the TTF, and which the folks do who are members, they'll submit it for testing, and they'll get a certificate. They'll put the certificate down, and then it gets credentialed, and you're good.
So you mentioned, suppliers or vendors that you actually trust. So that you guys trust in the US, or how are they going to be selected? Who is going to be certifying the rest, and as well, who's going to put all this together and fund it, and how is that will work? Sorry.
Could I also add, what is the testing standard?
So this is, Marley cautioned me, he wanted to bring all this up because he wanted to do it in steps, but I'm happy that I get a chance. So Marley hopefully won't be mad at me. So anyway, so it doesn't matter. Anyone in the universe can go ahead and actually, they can get the taxonomy and not even do this. They can just not put a logo on it. The reason why you're putting the logo, that you'd want to put the logo on it is to build some trust. There's no one who's saying who can or who can't. It's just as open source. So it works like, for example, in Wi-Fi or Bluetooth, there's, thousands of folks are doing it. It's totally neutral. Anybody can do it, and there's no judge or jury on whether it's right. But what we'll do with the TTI, we'll define by all the members what the features are that we all agree upon is the level of testing that would create some meat to it that would allow for, and it's all about interoperability, allow for interoperability so that somebody uses a token from one vendor, and it could be any vendor, any supplier, the token will work with, they can be interchangeable. They can have multiple vendors of choice.
Ramesh, I have two hats. I'm with IEEE Blockchain Initiative, working on some standards. I talked to Ron about setting up a relationship. That's one. Also, I have a startup, Bitcasa. We're tokenizing mortgage loans. We actually went live last week. It's very great. It's great work. I think it's the right time to start defining these things. Now the evolution of stable coins last year. Now talking about assets, tokenable assets. It's a perfect time to start this work. And so the question I had was, in the security tokens, right? When you start adding the legal restrictions into it, like, in the US, reg the accredited investors is like 12-month lockup period, and then, and then also transfer restrictions. In Europe and different countries, all these lockup period and all these things. How do you handle all of those into this? I mean, is it like a different? Is it even part of this, or is it not even part of the scope of legal restrictions?
So the intention is if it's something we can describe that the token needs to implement, whether it's a behavior or a restriction, then as long as it's described here and we can put that description here, I think it's valuable to put it in the taxonomy. But somebody still has to write the code for that, right? And that's but the first part of writing the code is understanding what the requirements are. So I think the taxonomy can play a part there. But if somebody's already doing that work, what we would rather do is have it there, but have it be a reference to the actual work that's done at a different body. We don't want to reinvent the wheel, particularly when it's jurisdictionally aligned with a particular region, like the EU or wherever, and make sure that's what we, and we'll get some more feedback on mapping and the references and things like that. But I think it's valuable to at least put a placeholder there so we can put it in the formula to say, hey, this token, but if you're going to apply it in this, it would be a leaf, right? That's why we have the node, and they say, here's the implementation for this region, and it has that behavior or restriction, which is a behavior, and that references to what that restriction is in that jurisdiction. Make sure you apply to that. And that would be how I would do it. I'm not saying that's how we're going to do it. I'm saying that's the approach. We think we could do it that way.
Hi, this is Arash Rady. I'm the Director for Cybersecurity Engineering for T-Mobile US. So the question I have is, this is a taxonomy definition, which to your point gets master biology, not software engineering very well. The question I have is based on the implementation of the token. Why should I trust one token versus the other? And where does the trust relationship come in? Who does the attestation from a security perspective for people to actually trust the implementation?
Yeah, so that's a really good question. The question is about attestation and things like that. So what, primarily from a tokens, we haven't, this hasn't been completely resolved, but I think the first level of standards and sort of attestation, we're going to test that this thing does what it says it's going to do. Whether it does it securely or not, that's an implementation detail. So that's just like multiple regulations, they're sort of layers of them. Right? You have the higher level. In data centers, one of you like the ISO standards, and they have there's like 5 or 6 that you have to comply with, and they're composable. I guess there's another way to do it. So we'd have those layers. So that would be an implementation detail that maybe when you do the reference and the mapping, we could bubble up so visually you could see that, hey, this, in the taxonomy, say this mapping reference has this attestation for secure code written in chain code from IBM. It's been through IBM. And then you're saying, okay, my trust is in IBM because I'm using their implementation. So it's sort of layered. That's not a perfect answer, but I don't think there's a great answer for that, but it's a layered one. Ron, if you want to think.
I have a response to that.
I'm 3 questions back.
All right.
You promised you'll give it back to me?
Don't trust them.
So the whole point of this is due to this great question, you don't trust them, right? So what we're ahead, and I'm just going to share with you a potential roadmap. It deals with regulators, and it deals with qualified custodians and insurance companies. And so the bottom line is, if these folks are issuing tokens right now, how are you going to get them on board? You're not. What we're doing is we're trying to make a better case to accomplish what you just asked, whereby if you have let's say an honest broker, you have an association or initiative where all the big players of the world are, and this is great that everybody's here, are all on you build more trust, because it's only about trust, even all the ways you do consensus, they're not 100% perfect. So we're about building trust, and what we're doing in this taxonomy, hopefully, will get us to the point where we can now get qualified custodians to sign up, because they can get insurance companies to back it. If we do that, and by the way, this is a roadmap. I am not even claiming we're remotely there, but if it's just our best shot at trying to get some kind of trust, because you don't have it like in the US, the FDIC, you put your money in the bank, you're secured for $250 million or whatever it is. There's no good answer to your question, but there's a route that we're thinking about to take to ultimately get regulators globally to support this. And the only way you do is you get the entire ecosystem in on it. And that hasn't happened yet. It's a major challenge for us. There you go.
Don't get it to her.
I'll take you down. So, yeah. announcement in February, but I come from the video game industry or the general counsel and chief lobbyist. And so I'm very pleased to see the work ahead here. I've been in regulatory and trade for a long time, and I can't help but look at this, and I am bouncing between the two conversations rapidly. This is fantastic. I mean, great job. An attempt to try and categorize the ocean is not easy, and I think this is really fantastic. That said, so it's not everything before the button doesn't matter, really does matter. But I am concerned. So I just filed yesterday like a 55-page response to our securities regulators who are trying to call all of this security, which is a really big problem. And I think it drives to bigger conversations that this has to move forward, but in tandem, there has to be another repository. GitHub's not friendly for non-techies. They're like, get what? Give us a Reddit or something. But I no, neither.
Okay, yeah.
Google Docs. No. But I do think there needs to be some aligned mapping. When we're talking about standards and trust, I mean, my brain automatically goes to ISO, and they have blockchain committee. There's conversations happen there. They'll be slow. I do think we need to have some kind of negotiated ESRB type standard body set up strategically globally, because the jurisdictional challenges are not going to go away anytime soon either. But what would really suck is to build an open source outcome that can't do anything, and you end up creating all these geo blocks in the code that doesn't serve anybody, and it kind of defeats the whole point of blockchain to begin with. So my main point, because I'm trying to catch up with all of the things that were said, my main point and my main question is, how can non-techies, the people who are steeped in these are like religious regulatory battles right now, how can we feed in and actively follow properly and get our KPMGs and our Deloitte who are refusing to audit in Canada at the moment, and the banks who are refusing to provide bank accounts, but yet both very interested in this? How can we get kind of all the stakeholders who are sort of competing and trying to undermine each other active on it? Because it will then build so much more credibility if we can show it's not just tech people in the room.
Right.
So how can we do that, and how can I help you?
Yes. So the first part is this does have a taxonomy, and it is in GitHub, but that's just it's like the Amazon's website that you shop on. It's got tons of SQL Server, databases and all that stuff, but it has a pretty web interface. So we're going to have a pretty web interface that you navigate the taxonomy. It's at tokentaxonomy.org. We just haven't put it up yet because we're still waiting to, we still have some things to find. So that will be there. The other thing I said early on was, because I agree with you, that there's some big problems that we have to face and we have to tackle. The problem that we had in the industry was that the main drivers, IBM, R3, digital asset, and you have others. So it's not just those, but in Microsoft, is we're trying to push on these, but we were pushing individually. This allows us to come together and push as one, and but it's going to benefit everyone, because we can put lots of, we have like full office staff in DC, just like IBM does. Everyone has staff, and this allows us to all sort of get together and charge the hill. I think we're going to have additional steps, like you're saying. How do we get this across borders? This is just the first step in building that trust. And trust is not something you earn immediately. Everybody knows this. It's earned over time with consistent actions. So this is hopefully not just the first step. I won't call it first step. This is standing on the shoulders of giants, right? Lots of good work that's occurred in the Ethereum community, and heck, before we even did blockchain, right? We were doing stuff like this. So anyway, I agree with you. Hopefully that sort of answered your questions. I encourage it. We anticipate that the people that are contributing to the taxonomy are not technical people. Can't hold a microphone on a shirt. So the technical people, once we get like the framework out and the basics and the website up and the process for you to add and update, it's like back off and empower the people that really know what the requirements are and they're driving business, and that's really the goal. Is hopefully that's what we're getting. I think we have enough critical mass across the industry to do that.
Hello, my name is Kirill. I'm solution sales from Credit Blockchain, Deposit Class 50 consensus protocol. My question is, so what do you think the top 3 use cases for tokenization which will change the entire world of all end users, like all of us?
I don't want to say what that is right now, but hopefully we'll define that in the taxonomy. Somebody will come up with that formula that's going to be, I mean, we've seen some examples today, but I think the thing that a lot of us have been in this industry, well, we focus a lot on something that's a financial thing. But at Microsoft, we deal with industries all around the world of every stripe and color. And we dig just a little bit in any healthcare, media and entertainment, and you dig a little bit, and it's just a huge opportunity. So I think the stuff that we've done to date on securities and cryptocurrencies is a drop in the bucket. Once we start to give this goodness and spread it around, this is like the first step, because I don't know, but I think this group can help us figure what that is, and get there faster because we're sharing across industry. Because it's really good to cross industry killer scenarios. That is a healthcare solution, but really it's got finance and insurance and all sorts of things in there, or it's one in media and entertainment that is tied to some next generation VR glasses or something that you can wear on a plane. Who knows? But this is going to let us speed that up.
Hi there.
What questions?
No, yeah. So on one side, like we are talking here about kind of like creating a unified language for like trustless system. On the other side, we are talking about like certification, kind of like putting trust into the initiative. So my question would be like, I understood that there is no plan for the initiative to come up with implementations, but how about the testing suite? Like, do you assume like the initiative will create an open source testing suite, which would be at least like verifiable from like any party, where the implementation would be public, the testing suite would be public, so anyone could like verify that particular implementation passed the test?
So the answer would be yes, and it would be taught at R3. Well, there'll be one for Corda, right? There'll be some for Ethereum and Quorum and Pantheon and the Ethereum sort of suite. And IBM will have one for Fabric. So this will let them justify them carrying the water for building that, because for us, if we make it easier for you guys to build tokens on our platform and have them certified, we're the ones who have that incentive to build this test services, that you can quickly certify your token implementation on my blockchain, and it's going to feed my ecosystem. So it allows us all to play on our strengths and also lean in and justify to our management to say, hey, I need to have resources to do this thing that isn't going to contribute to the bottom line directly, but indirectly, it's really important. So, I mean, underneath the covers, when you look at why is IBM and R3 and digital asset and Microsoft coming to do that, I mean, look at what our sick motivations are. We want you to build on our stuff, right? Sick and twisted motivations. Sorry about that, but that's just the way we'll work. So we have bosses and we have pay bills and stuff like that. But hopefully that answers your question, and hopefully the natural incentives will work there. But at least we'll all do it in a consistent way, right? That's the plan. And that was the agreement between us. And we did it in blood oath and secret ceremony with Masonic symbols all around. I'm kidding. We all know that's the right thing to do.
I think I missed that part, Marlon.
You missed the Masonic symbol part?
We'll catch up.
Yeah, okay.
So I'm Jared Quay. I lead Digital Assets. Coming back to the regulatory question, the second big motivation is that right now, and if you look at where IBM fits in the industry, we're not a financial services institution. We have no interest or plans to become a bank or banking license, money services business, or take your pick. But the challenge right now, and I think the characterization is correct, is that the default mode on a global regulatory scale is with a handful handful of exceptions with a couple of jurisdictions to just lump things under a securities apparatus. The challenge is that's very difficult to actually challenge that statement unless you have a consistent way you can describe how the world works. And I am not technical, so the comment on the technical need to translate, I don't understand most of what happens in digital. But I do understand the language we're using to explain it. So once we can get the basics and we can translate out of the developer world into a set of terminology that's understandable, we can look at an asset and say, this is what does, and this is how it behaves, and this is how people interact. That has to be backed up by code. Having metadata described as good, having reference implementation of how it works on the individual blockchain is better. Because at the end of the day, I, as a business person, can sit there and describe it, but that's actually got to be reality. So the place to start is in the reality. Work up towards a set of terms that describe what reality is doing. Now, when you go sit down with regulatory bodies, you can say, this is what's actually happening, and this is how it behaves. That frames it in a way they can understand. If you go and you look at, the U.S. is a bit funky, but if you go and you look at what is a stock, what is a bond, and so on and so forth, not only do you have the securities apparatus, you have a set of attributes that come with it. You actually have standards around it. Things you have voting rights, you're entitled to distributions, so on, to dividends and other types of distributions, so on and so forth. It's that very language that we've got to start in the technical version, the implementation, describe in a generic sense with metadata, translate back into English, and then you can sit down with the regulator and say, it has these attributes but not those ones, so it kind of looks like this, but not entirely. And that's why that's a huge reason why we're at the table, so that we can get to that level of clarity, which then allows IBM to operate in various domains.
Your sick and twisted ways.
Sick and twisted way. In various domains, and in some cases, we'll be able to play a larger role because it's outside the strict regulatory schemes, and in other places, we'll have a backseat role and let the appropriate licensed institutions take on that set of responsibility.
I just want to alert everybody we're over the time by 30 minutes. So these are all really great questions, and I'm loving listening to them, but we have to kind of keep the schedule moving, that way we're productive. So I just want to wrap that up. I mean, I'll let you add your last statement, or if you want to catch Marley afterwards, that would be great, but I did have to kind of pop in and say we're over the time.
We can, if we want to collect the questions from the WebEx, we can respond to those in an email back, or we'll respond back to the questions on GitHub if they weren't, on WebEx if they weren't answered, but we do need to go ahead and shut the WebEx down, and then we'll continue on. So with that, we'll close out the WebEx meeting. Got it?